right, folks, we're going to do station number 3 of the Law Conservation of Mass stations. Experiment number 1 is mixing sugar and water. So procedure, follow the directions listed out on the syllabi to complete this experiment. Number 1 is mixing sugar into water and dissolving it a physical or a chemical change. Explain. Well, it's a mixture. So we're dissolving the sugar into the water. If we evaporated all the water out of the beaker, we'd be left with a crusty sugar residue left over. So hopefully that gives you a hint as to whether mixing sugar into water is a physical or a chemical change. Make sure you explain why. Make sure you pause the video if you need to write in number 2 for experiment 1. If our experiment followed the law of conservation of mass, and explain what could have caused the error. All right, so on this procedure, it says use the scale to measure out 3 grams of sugar in the weigh boat, and I have 3 grams of sugar. The next step in our experiment is to pour 60 milliliters of water into a beaker, which I have right here, and then put the beaker with the water on the scale and see how much our beaker plus water weighs, and we're gonna write it on our paper. So 106.61 grams, we're gonna write it right here. So 106.61 grams. I've written it right there. All right, next, we are going to predict the total mass of the beaker plus the water plus the sugar. Well, according to the law of conservation of mass, probably gonna be 3 grams plus 106.61. So you write your predicted total mass in right now. All right, and then we are going to actually weigh our sugar. We have 3 grams of sugar here after we've poured it into our beaker. All right, make sure we got everything in there. We're gonna stir it up until it's dissolved. That's pretty good. Okay, so our actual total mass of the beaker plus the water plus the sugar is 109.63 grams. Okay, I have it here. So that's pretty close to our predicted total mass. All right, our second question says, did your experiment follow the law of conservation of mass? If not, explain what could have caused the error. Well, I mean, it should have been 0.61, but it was 0.63. That's pretty close. So what do you think could have caused the error? Well, I know that these scales aren't super accurate, so maybe it could have been the scale. Maybe it could have been some sort of calculation I did. But why don't you fill in if your experiment followed the law of conservation of mass? So moving on to experiment number 2 on station 3 in the law of conservation of mass stations is putting Alka-Seltzer into water a physical or a chemical change. Explain. Well, if we think back to our lab at the beginning of this unit called the PC Changes Lab, one of those stations was putting Alka-Seltzer and water together, and we saw a bunch of gas bubbles being produced. And so if there's gas bubbles, is that a physical or a chemical change? Make sure you use at least one piece of evidence to explain. All right, so on our procedures, our first thing is we're going to weigh 1 tablet of Alka-Seltzer. So this Alka-Seltzer tablet, mass of the Alka-Seltzer is 0.6 grams. All right. Next, we have 60 milliliters of water, and we're going to weigh the mass of the beaker plus the 60 milliliters of water. Oh, we gotta tear it again. Okay. So 108.54. 108.54 grams. Okay, so the next thing we're gonna do is we're gonna predict the total mass of the beaker plus the water plus the Alka-Seltzer. So you're going to make a prediction right there. So write in your prediction right now. So hopefully you took time to pause the video if you needed to make your prediction. If you need to pause, go ahead and pause to write your prediction down. And then our next step is we are going to record the actual mass of the beaker and the water and the Alka-Seltzer. So I'm putting the Alka-Seltzer in. Ooh, I can see lots of gas bubbles being produced right now. Okay, interesting. Oh, it went down. 109.12. So it looks like the tablet's pretty dissolved. So our actual total mass of the beaker plus the water plus the Alka-Seltzer is 109.12 grams. So, did your experiment follow the law of conservation of mass? Well, If not, explain what could have caused the error. So, it decreased a little bit. So we saw gas bubbles coming out of here, right? Gas, when it escapes, it goes into the air all around us. And so it's really hard to weigh that air once it's been released from our solution. So it would kind of make sense that our numbers decreased a little bit. So if I added just 108 plus 0.4 and 0.6 together, I would get 109.14. But the actual total mass was 109.12 or 11 even. So did the experiment follow the law of conservation of mass? If not, explain what could have caused the error. And then my last question is, how could you design an experiment so that no mass is lost when the Alka-Seltzer is added to water? So what could you do to this experiment to change it so that the gas bubbles from here didn't escape into the air, that they were still right here in our beaker? So what could you do? So write that in for experiment number 2, and we're all done with station 3.